Good morning. On the last period we have started about thermodynamics. What is thermodynamics? A branch of physics which deals with heat and temperature and interconversion of heat and their form of energy. Zeroth law. If two systems are in thermal equilibrium with third system, if two systems are in thermal equilibrium with third system, then all three systems are in thermal equilibrium with each other. Then about heat. The transfer of energy between systems or between system and surrounding due to temperature difference between them is called as heat. What is heat? The transfer of energy between pairs of system or between system and its surrounding due to temperature difference between them is called as heat. If temperature of system is greater than temperature of surrounding, then heat losses by system to surrounding, and hence temperature of system decreases and transfer of energy is negative. If temperature of system is less than temperature of surrounding, then system gains heat from surrounding and hence temperature of system increases and transfer of energy is positive. But if temperature of system is equal to temperature of surrounding, then neither heat lost nor gained and hence temperature of system remains constant. Then we have seen about internal energy. The energy associated due to random disordered motion of molecules as well as interaction between molecules is called as internal energy. What is internal energy? The energy associated with random and disordered motion of molecules as well as interaction between them is called as internal energy. For monoatomic molecules, internal energy due to only translational kinetic energy of molecules. For polyatomic molecules, internal energy is due to sum of translational, rotational and vibrational kinetic energies of molecules. Then thermodynamic system. A collection or group of objects that forms a unit. A collection or group of objects that forms a unit which may have ability to exchange with its surrounding is called as thermodynamic system. There are three types of thermodynamic systems, that are open system, closed system, isolated system. Open system. A thermodynamic system in which both energy and matter exchange with each other. A thermodynamic system in which both energy and matter exchange with each other is called as an open system. Closed system. A thermodynamic system in which only energy is transferred but not matter with surrounding is called as closed system. And isolated system. A thermodynamic system in which neither energy nor matter exchange with surrounding is called as isolated system. Then thermodynamic process. The process in which thermodynamic variables, that are pressure, volume, temperature, changes. A process in which thermodynamic variables such as pressure, volume and temperature changes is called as thermodynamic process. when for example, when a container containing water closed with a lid and is heated, then temperature of water increases and hence pressure as well as volume increases. Means if temperature changes, then both pressure as well as volume changes, like this. Now, relation between heat and internal energy. Relation between heat and internal energy. Internal energy. The internal energy of system may change or can be changed by either heating or doing work on system. म्हणजेच एखाद्या सिस्टीमची इंटरनल एनर्जी कधी चेंज होत असते, जर समजा त्याला आपण हीट केलं किंवा त्याच्यावरती वर्क केलं. एखाद्या सिस्टीमला समजा आपण हीट केलं किंवा त्या सिस्टीमवरती जर वर्क केलं तर मग त्याची इंटरनल एनर्जी चेंज होत असते. सी फॉर एक्झाम्पल, consider a cylinder filled with gas with airtight, massless and frictionless piston. Suppose this one as a cylinder filled with some gas. Consider a cylinder filled with some gas provided with movable, massless and frictionless piston, airtight part. If Ts, that is temperature of system, Te temperature of environment, if cylinder is brought, suppose this one as system, if cylinder is brought in contact with source of heat, if cylinder is brought in contact to source of heat, then energy is transferred from source of heat to system and hence internal energy of system increases and change in internal energy is positive. If Ts is greater than Te, means if temperature of system is greater than temperature of surrounding, then energy is transferred from system to source of heat and hence internal energy of system decreases and change in internal energy is negative. This is about heat. Now, work. If piston is pushed inside cylinder, then work is done on gas. If piston is pushed inside cylinder, then work is done on gas and hence temperature of gas increases and change in internal energy is positive. If piston is pushed by gas or if gas pushes piston outward, then work is done by gas on piston and hence temperature of gas decreases and change in internal energy is negative. Now, today we are going to see first law of thermodynamics. First law of thermodynamics. First law of thermodynamics. The change in internal energy of system, the change in internal energy of system is equal to difference between heat supplied to the system is equal to difference between heat supplied to the system and work done by system on surrounding, that is W. See once more. The change in statement, the change in the internal energy of system, the change in internal energy of system म्हणजे एखाद्या सिस्टीमची एनर्जी किती चेंज होते, एखाद्या सिस्टीमची एनर्जी किती चेंज होते हे कशावरती डिपेंड आहे, तर त्याला आपण किती हीट सप्लाय करतो. हीट सप्लाय केल्यामुळे त्याची एनर्जी वाढेल, पण त्याच वेळी सिस्टीम एन्व्हायरमेंट वरती किती वर्क करतं तेवढी एनर्जी कमी होईल. मग त्या दोघातला डिफरन्स म्हणजे चेंज इन इंटरनल एनर्जी. The change in internal energy of system is equal to difference between heat supplied to the system, heat supplied to system and work done by system, work done by system on surrounding. The change in internal energy of system, the change in internal energy of system is equal to the difference between heat supplied to the system and work done by system on its surrounding, and therefore total change in internal energy del U is equal to Q minus W, which implies quantity of heat supplied or amount of heat supplied is equal to change in internal energy plus work. This is mathematical form of first law of thermodynamics. What is first law of thermodynamics? The change in internal energy of system is equal to difference between, कशातला डिफरन्स आहे, the heat supplied or quantity of heat supplied to the system and work done by system on its surrounding. This is mathematical statement of first law of thermodynamics. Now work done by gas, work done by gas म्हणजे एखादा गॅस हा किती वर्क करतो हेच एक्झाम्पल इथे आपण पाहूया. कन्सिडर अ सिलेंडर filled with gas provided with movable, massless and frictionless piston like this. Consider a cylinder filled with some gas provided with movable, massless and frictionless piston. Let A, that is cross sectional area of piston, P, constant pressure exerted by gas on piston. मग या पिस्टन वरती निर्माण होणारा प्रेशर म्हणजे आतला हा जो गॅस आहे हा याच्यावरती किती प्रेशर निर्माण करतो, P, that is constant pressure exerted by gas on piston. Then force exerted by gas, तर तो गॅस किती फोर्स निर्माण करेल. ऍक्च्युअली प्रेशर इज नथिंग बट फोर्स पर युनिट एरिया and therefore force exerted by gas F is equal to P into A. This is force exerted by gas. If suppose dx be the small displacement of piston, let dx with small displacement of piston, then work done by gas on piston. What is work? That is force into displacement. Force, that is P into A into dx. Okay. This is small work for small displacement, and hence total work done by gas, and therefore total work done by gas by increasing volume Vi to Vf. समजा इनिशियल व्हॉल्यूम आहे Vi, फायनल व्हॉल्यूम आहे Vf. म्हणजे एवढा व्हॉल्यूम या व्हॉल्यूम पासून ह्या व्हॉल्यूम पण चेंज होत असताना किती वर्क निर्माण केलं जातं. देन टोटल वर्क डन बाय गॅस टू चेंज व्हॉल्यूम फ्रॉम Vi to Vf, work is equal to integration of dW from Vi to Vf, which is equal to integration of P into A into dx from Vi to Vf. Okay. See here, this is nothing but change in volume. P into change in volume, and this is therefore which can write integration of P into change in volume from Vi to Vf, or which may be written as P into Vf minus Vi. This is work done by gas. This is an expression of work done by gas. परत येईल बघा. आता आपण काय काय पाहिलं. फर्स्ट लॉ ऑफ thermodynamics, the change in internal energy of system, the change in internal energy of system is equal to difference between, कशातला difference आहे हा, the heat supplied to the system and work done by system on its surrounding. The change in internal energy of system is equal to difference between heat supplied to the system and work done by system on its surrounding. तर हे किती वर्क होतं? Work done by gas. Consider a cylinder filled with airtight, movable, massless and frictionless piston. Let A cross sectional area of piston, P constant pressure exerted by gas on piston, then force exerted by gas. F is equal to P into T. खर तर गॅस त्याच्यावरती एवढा फोर्स निर्माण करणार आहे. If dx, that is small displacement of piston against this force, small displacement of piston against this force, then work done by gas. Work done by gas, that is force into displacement, but A into dx, A cross sectional area, dx change in or displacement factor mana, and therefore A into dx is nothing but change in volume, and therefore total work done by gas on piston by increasing volume from Vi to Vf, that is W is equal to this work like this, but this is nothing but dV, that is P into Vf minus Vi. First law of thermodynamics, and work done by gas like this. Now, one more point about thermodynamic variables. Thermodynamic variables. आत्ताच मी तुम्हाला सांगितलं होतं any measurable or observable characteristics or properties of system. Any measurable or observable characteristics or property of system such as pressure, volume, temperature, density, mass, internal energy, like this. When system is in thermal equilibrium, when system is in thermal equilibrium are called as thermodynamic variables. Definition. What are thermodynamic variables? Any measurable or observable म्हणजेच मेजर करता येणारी किंवा ऑब्झर्व होणारी कॅरेक्टरिस्टिक्स और प्रॉपर्टी. एनी मेजरेबल और ऑब्झर्वेबल characteristics or property of a system such as pressure, volume, temperature, density, mass, internal energy, etc. when system is in equilibrium. ही एक कंडिशन महत्वाची आहे. सिस्टीम इक्विलिब्रियम कंडिशन मध्ये असताना ज्या क्वांटिटी मेजरेबल असतात, ऑब्झर्वेबल असतात त्यांना म्हणतात थर्मोडायनॅमिक व्हेरिएबल्स. What are thermodynamic variables? When system is in equilibrium, when system is in thermal equilibrium, then any measurable or observable characteristics or property of system such as pressure, volume, temperature, density, mass, internal energy, etc. is called thermodynamic variables or are called thermodynamic variables. Thermodynamic variables which are not depends on size of system are called as intensive variables. Intensive variables. The variables which are not depends on size of system. Size of system. म्हणजे त्या सिस्टीमची साईज किती आहे त्याच्यावरती हा चेंज अवलंबून असतो किंवा ते व्हेरिएबल अवलंबून असतं. The thermodynamic variables which are not depends on size of system are called as intensive variables, and that variable which are depends on size of system are called as extensive variables that are depends on size of system. There are two types of variables. Thermodynamic variables, intensive variables, extensive variables. The thermodynamic variables which are not depends on size of system are called as intensive variables, and the variables which are depends on size of system are called as extensive variables. For example, when system is in equilibrium, is divided into two equal components, then pressure, temperature, density remains constant, are called as intensive variable, but mass and internal energy of each component are changes, are called as extensive variables. बघा, intensive variables, extensive variables which are not depends on size intensive, depends on size extensive. For example, when a system is in thermal equilibrium. Suppose this one as a system in thermal equilibrium is divided into two equal components. Then pressure, त्यानंतर temperature as well as density remains constant. Pressure, temperature, density remains constant are called as intensity variables. But mass, internal energy of each component changes. Volume, mass, internal energy of system, each component are changes are called as extensive variable. Mathematical relation between state of variable, that is PV is equal to nRT. This is mathematical relation, that is PV is equal to nRT. N, that is number of moles, R universal gas constant, T absolute temperature. Okay, this is about. आज आपण फक्त एवढंच पाहिलं. फर्स्ट लॉ ऑफ थर्मोडायनॅमिक्स, वर्क डन बाय गॅस, त्यानंतर थर्मोडायनॅमिक व्हेरिएबल्स. नेक्स्ट पार्ट ऑन नेक्स्ट पिरियड. ओके.